Have you ever been puzzled by a piece of code that works perfectly in one compiler but throws errors in another? It's frustrating, right? If that's you, then you're in the right place. Today, we're diving into a snippet that works in MSVC but not in G++ or Clang. I totally get it. You write your code, it runs smoothly in one environment, and then you switch compilers only to be met with errors. You're not alone in this struggle. Many developers face similar issues when transitioning between different compilers. Here's the specific situation we're looking at. A user recently asked, "Why does my SFINAE snippet work in MSVC but not in G++ or Clang?" They provided a code snippet that compiles fine in MSVC but throws an error in G++. Sound familiar? Let's dig into this together and find a solution. So what could be causing this discrepancy? The issue often lies in how different compilers handle SFINAE, or substitution failure is not an error. We'll break it down step by step so you can understand what's going on. And don't go anywhere. I've got a crucial insight at the end that will help you navigate compiler differences more effectively. To understand why the S snippet works in MSVC but not in G++, the user should first check the compiler settings. Ensure that the correct C++ standard is being used. In this case, the user should compile with the C++17 standard. Next, the user should examine the SFINAE implementation. The issue arises because G++ and Clang are stricter in their interpretation of SFINAE. The user should modify the check function to ensure it properly handles non-class types. The user can also consider using a different approach for type checking. Instead of relying solely on declval, they might use a more explicit type trait that can handle the case of non-class types more gracefully. Finally, the user should test the modified code in both compilers to confirm that it behaves as expected. This will help ensure compatibility across different environments. Fun fact, the term SFINAE was coined by David Abrahams in the early 2000s. It's a powerful feature of C++ that can save you from many headaches when it works as intended. Now let's look at the answers provided by other users. This user suggests an alternative approach using a library called CanApply. This library simplifies SFINAE by checking if a template can be applied to a set of types. They provide a way to define traits like has.size, which checks if a type has a size method. They also introduce a can-invoke function that tests if a function can be called with given arguments. This allows for more flexible function calls, returning a default value if the call is invalid. That wraps up that answer. Let's move on to another one. An alternative solution provided by a user involves using std_enable_if to SFINAE away the template version of the check function. They suggest excluding fundamental types like int and float from instantiation. This approach allows the code to compile successfully in both Clang and G++. The user also mentions that compiling with the matstd++1z flag for Clang and G++ should work, and they expect that using matstd=c+14 would also be effective. Here's the insight I promised. Always test your code across multiple compilers. This practice can help you catch these discrepancies early and make your code more portable. And there you have it. With a few adjustments, you can make your SFINAE code work across different compilers. Remember, understanding compiler differences is key to becoming a better developer. If you found this helpful, hit the subscribe button for more tips, and don't miss our next video on advanced C++ techniques.